Hello everyone, I'm Alfian and today we are going to solve the Leetcode challenge of the challenge number is 1512 and the name of the challenge is the number of good pairs. For this particular challenge, given an array of integer nums, return the number of good pairs. The good pairs is a pair that is the same to one to another. A pair of I and j is called good if nums I is equals to nums j and the I is below the j. And let's say the input example right here is 1, 2, 3, 1, 1 and 3 and the output is 4. And there are 4 good pairs, for example on the index 0 which is 1 and with the 1 right here which is on index 3. And another one is index 0 with the index 4. 1 and 1, they both have the same numbers, and so that's why it's called a good pair. And for the next one is 3 with 3, which is index 2 with the index 5 as stated right here. And the last one is 3 and 3, and the last one is 1 and 1 right here, which is on index number 3 and index number 4 as stated right here, and they are called the good pairs. And for the example number 2, the good pair has the amount of 6 because it's all interconnected to one another. Let's say index 0 with index 1, index 0 with index 2, index 0 with the index 3, and it's already 3. And then for the next one, which is index 1 with the index 2 and index 1 with the index 3, which is already 6. And for the it's already 3 for the first one right here at the 3. Let's say we have one of the index 0, let's say A, with the 1b, 1c and 1d, and the pair is already 3, counted 3. And then for the next one, the 1b wouldn't compare to the 1a again because it's already clear before with 1a with 1b. Let me pair it with 1b, and then 1b will not pair with 1a again because it's already declared, and we avoid the copying the good pair. So we need to pair with the unique index is 1b with 1c, and it's interconnected with one another, and then 1b with 1d, and then for the last one, which is 1c with the 1d, and not 1c with 1b because 1b is already paired with 1c. And then 1d is not going to pair to either 1a, 1b or 1c because 1d already paired with the 1a and 1b and 1c before that. So that is why it's returning only 6 number of pairs. And for the next one, which is index of 0, 1 and 2 of nums, they don't have the pairs at all because they have all unique numbers without the same number, so that's why it's only returning 0. Since we are implementing it using the Java, and we look over the hint number 1, it says count how many times each number appears. If a number appears n times, then n times the n subtracted by 1, it covered in a parenthesis and then divided by 2. And this is the pairing formula, and when we can utilize this later as we progress our code by iterating the array of nums. And so before that, I had an implementation. It was really complex by using the 2 pointers with iterating the whole array right here using 2 pointers. Let's say if I have 1, 2, 3 and 1, and then for the 2 pointers we'll be comparing 1 with 2, and then 1 with 3, and then 1 with 1. And then for the next one, of course, we are comparing 2 with 1, 2 with 3 and 2 with 1 again, 2 with 1, 2 with 3 and 2 with 1 again. And that will take me a lot of times because the complexity of the result will be O and with the power of 2, which is the quadratic complexity of the time complexity, and it depends based on the number of elements inside the array. And we don't want to implement that, but instead we can use the special JavaScript variable called the map, and then iterating the and then using the integer of the key value pair of both integer as the data type, and then let's declare the name with the name is Hashmap, and then equals, we construct new Hashmap by using new Hashmap, and then for the data type or the using the diamond operator inside the data type is both key value pair of both integer, and then don't forget to invoke this using the parenthesis right here. And if you're implementing it in your own IDE or Leetcode, then you need to use import java.util and map. For the next one, importing the Hashmap by using java util and Hashmap. And I believe on the Leetcode they already provided the import using the java.util. Using the asterisk sign. It's a wildcard to import everything, including the map and the Hashmap. And for the next one, we have to iterate our array, and then after we iterating the array, then we can count the number, the value that is always showing up for every iteration. And after we get the value, we need to calculate individually using the pairing formula right here. We already get the hint, and we need to utilize this by using the for loop, or using the integer of I 0 as long as I is below the nums of length of the nums array parameter right here, and then we incrementing I by 1. And inside the for loop we can declare the Hashmap using the special put function right here. We are putting the key value pair into the array based on the index of the nums right here, or the element of the current nums iteration right here. So let's say for the nums for the first iteration is 1, then we assign the key of 1 as the key, and then we are counting the value as how many ones that are inside the array of nums right here. And in order to get the amount of 1 inside the nums, then we need to iterate it just one time using a single pass, and then we have the value right here. The key is 1 and the value is 3, because 1 there are three occurrences of 1 inside the nums array. Using the put, if we look over the with W3 schools right here, and for the Hashmap methods we have the put to write an entry into the map, and using the put right here, let's access this to see what is it about. And we are assigning the key as England and the value of London. So let's go back to our implementation, and we already get the better idea of it. And then we are assigning the nums of the index as the key, and then for the second parameter is the using the same Hashmap again to get the value, or the using the value of the key, we get the value from the assigned key inside the Hashmap.get. I believe it's get. Let us go back to get function from the Hashmap. And the get right here return the value of the entry with a specified key, and then we are getting using the key. And then if we run this, getting the key of England, then we will get the London value right here. And let's go back to our implementation, and we get the value by using the nums of the current index, and then the get function right here will be returned, I believe it's returning either null or undefined. Then we need some kind of fallback by using something other than get. Then we can use something called the get.OrDefault. It's listed right here as the function, and it says return the value of the entry with a specified key for or a default value if the entry is not found. And I believe it takes two parameters. The first parameter is the key that we need to obtain from the England key, And if England is not exist, England key is not exist, then the fallback value will be unknown, and we can utilize this by using get.orDefault function and nums I, since it's already as the first parameter, and then for the second parameter we have to use a fallback of 0, and then we can, for the next one, we can add it by 1 to check if the nums of the current iteration has the value of the key value pair inside the Hashmap. If it is, then we have to put the value inside the same key by 1 right here. And for the next one, you might want to see the result from the Hashmap key value pair using the system. Let me show this by using system out print line of the Hashmap, and don't forget the semicolon, and then we simply use the return 0 as our placeholder right here. So let's run this code to see what is it about. And we have an error, cannot find symbol new Hashmap. I believe it's Hashmap with the capital M, and also the same thing goes to the java.util.hashmap. So let's run this again. Okay, so on the nums array right here, there are 3 occurrences of 1 integer right here, and yeah, it says the key of 1 has 3, and the 2 right here has only 1, and the 3 right here has 2 occurrences of 3. So that is why the key value is 3 and the value is 2. So after that, we can use the pairing formula right here by using the for in I equals 0 as long as I is below the Hashmap, and to iterate the Hashmap one by one to check the how many entries that in Hashmap, then we can simply use the map methods. Let's see, using the size, return the number of entries in the map. It's the same as using length of the array. Hashmap.size function and then I++. Since we are iterating the key value pair, we cannot get the key value pair because we are only have the I right here. Since we are iterating the Hashmap instead of using array, then we can use the for integer of value, and then by using the what is this sign, I believe. Okay, so we are using the colon sign, not the semicolon, and then we are iterating our Hashmap. Since we are using the for loop of the Hashmap, then we can use the values function right here, and we return a collection containing all of the values in the map, and then we are returning the collection of all of the values, and then we can iterate it since it's in a form of collection. Okay, so let's use this by using the Hashmap values as values function, and then inside this we can get the system out print line. We can get the each value inside the Hashmap by using the value as the system out print line. So let's run this to see what is it about, and we get 3, 1, and 2, just like the Hashmap before using key value pair, and then we only get the value of the for loop iteration right here, special for loop. And then in order to get to calculate using the formula right here, we can use this individually by declaring our integer, which is good pairs. We name it good pairs, or you can name it pair or anything to check how many pairs inside it, and we declare it using 0. And then for the return, we can simply return good pairs, and for the operation of the for loop of the Hashmap, we can simply insert good pairs equals of the current good pairs plus the 3 right here, the 3 occurrences of 1, and 1 occurrences of 2, and 2 occurrences of 3 right here. And then we can use the value times using the parenthesis value minus 1, and if you look over the hint right here and divide it by 2, And this way we are calculating the previous good pairs, adding it using the value of the n right here. Now we already get the value n, and then times the parenthesis of n minus 1, which is value minus 1, and then divided by 2. So this is the main formula of the pairing formula. And then we can simplify this by using the good pairs with the plus equals operator, so it does the same thing, and by calculating the previous good pairs with the value times value minus 1 divided by 2. And then you might be wondering why we should use the parenthesis of the subtraction right here, because we are following the PEMDAS rule, or the parenthesis as the p. It will be calculated first because it's in a parenthesis, and then the e or the, let's see, what is e? E is exponent. And let's go back to our code. E is exponent, which is the power of 2 or power of 3. And then for the next one, which is multiplication, so after we are subtracting the one that is inside the parenthesis first, then we can multiply it by the value right here, and after that the d, which is the division takes after the calculation after the multiplication right here, and for the rest is addition and subtraction. And let's run the code to see if it works. And I forgot to include the semicolon, forgive me for my mistake. Let's run the code again. And there you have it, with the runtime of 1 millisecond and the memory of, it's not so great. So for the next one, I will implement the similar one using the TypeScript, and then the name of the function is num identical pairs with the nums parameter in a data type in a form of array of number or array of integer, and the expected output is in a form of number. And we can simply declare our Hashmap using the constant Hashmap, and then we declare new map since we are using TypeScript. And then for the data type is the key of the number, type number, and the value of the type of number. And then for the next one, we can do the same thing using the for loop, for let I is equal 0 as long as I is below the nums.length and I plus. And that way we are iterating our array right here. So let's iterate this by using the Hashmap with the function of set, in the set. And for the first parameter, takes the key of the current index, which is the nums of I, so we can get the1 as the key. And for the next one is the Hashmap, getting the value of the Hashmap to see if it's there or not by using the get of the nums I, and then we get, and the parameter is the key, and the get function will be resulting in as the output of value, and then get I, and then we obtain the value from the Hashmap right here using the key of nums.I of the current iteration. And then we can use the fallback of 0, and the TypeScript is more simpler because the fallback is just using the double pipe operator right here. Instead of using get or default in Java, you can simply use the get double pipe operator and then 0. That way we are checking if the Hashmap get is null or undefined, then the fallback value will be 0, and that way we are avoiding a type error or the output error, and then adding it by 1 using the plus 1, and simply use the return 0 as a placeholder if you want to look the content of the Hashmap. And we can use console.log Hashmap, and let's run the code. And the std out, which is the standard output of the console.log, is in a form of map, which is the key of 1 as the value of 3, because the array right here has 3 occurrences of 1, just like the rest of the Java implementation. And there you have it. And for the next one, we can use the for loop, but before that we can simply declare a variable called the let good pairs and then 0, and using the for loop to check. Let me delete this first. In TypeScript, just like in Java, we cannot use the for loop of the let I and then equals 0 and then I as long as I is below the hashmap dot length of hashmap or length of or the size. Then we can simply iterate it using the for, I believe it's number or a constant. Yeah, it's constant value using the of instead of colon in Java, value of hashmap dot values, and to check it to see if I am not wrong. And let's run this in the console.log of the value right here. Okay, so just like in Java, it's similar using the for of loop, and we are iterating the values, all of the value inside the hashmap.values as the iterable object of the hashmap right here. And then we can use the value as the good pairs, just like in Java, good pairs with the plus equals sign or plus equals operator. Then we are adding the good pairs with the previous one with the value times or the multiply as the n right here. Value is the same as the n, the value minus 1, and then divided it by 2, and then the return value will be using the good pairs. And let's run the code to see if it works. And there you have it. But let me show you something more concise. Instead, by using the good pairs right here, then we can simply use another constant of the good pairs, and then inside the good pairs is we are iterating the hashmap content right here using the array from hashmap values, I believe it's hashmap values, and then chain it with the reduce function since we are using the TypeScript reduce. And for the first parameter takes the accumulator, and for the second parameter, which is the current of the current iteration, and we are using the anonymous arrow function. And that way, let me delete this again, let me redo this again, arrow function. And then for the second parameter, which is 0, this is the default value of the accumulator right here. And so for the arrow sign, for the arrow function, we can simply use the accumulator plus the current times current, inserting it in parentheses, current minus 1, and divide it by 2, and then we can return the good pair again. Let's see if it works. If I remember correctly. So let's submit this. And there you have it. You can make it more simpler by not declaring the good pairs constant, and then we can simply directly return it using the array from hashmap.values as the iterable value inside the hashmap, and then using the reduce, then with the reduce with the accumulator and current, and using the arrow function, and then calculating the accumulator, which is 0 right here. The same goes as the good pairs right here, the accumulator acting as the good pairs right here, and for the first initial number, which is 0 added by the current of the formula right here of the description and the hint, and then we are iterating all of the value right here, and that way it is the same thing as using the for of loop. But this kind of implementation is not that readable, that we need to balance between readability and efficiency. So I will stick to the let good pairs is equal 0 and then returning the good pairs, and that way it is more readable compared to the using the reduce. It's about the preference. And you might be wondering why is it still using the pairing formula of the n right here, the n times the n minus 1 and then divided by 2. That way, let's see if let's add let our doodle right here. Let me enlarge the screen. let's see if we have nums of 1, 2, 3, 1, 1, and 3. And then for the first one, which is 1a right here, let me name it 1a, has a friend, not has, have two friends called the 1b and 1c. And 1a paired with the 1b and pairing with the 1c. And that way we have 3, which is value right here of consisting of 1a, 1b, and 1c, like this 1a, 1b, and 1c. We have 3 of the value right here. And then since each individual will not be pairing with themselves, then we use the value subtracted by 1. It is, this definition is the same as using 1b and 1c right here to resembling a friend of 1a, value minus 1. And then we can, and then for the division of 2 right here, it's about, let's see if we have 1a and 1b and 1c. For the pair, we can use this as 1a with 1b, and then for the next one with 1a with 1c, and then 1b with, not with 1a because it's already declared right here, 1b with 1a, and then 1b with 1c, and then 1c with 1a, and 1c with 1b. And then the unique pairing right here, this is all of the possible pairing to one to another. Let's say we have 1a and 1b, which is valid, and 1b and 1a, which is invalid because it's already declared before. And for the 1a and 1c, which is valid, and 1c with 1a, which is invalid because it's already paired before. 1a already paired with 1c. It's the same as 1a with pairing with 1c right here. And for the next one, 1b with 1c, and 1c with 1b again, which is invalid. So that is why we only have 3 pairings of 1a between 1a, 1b, and 1c. So that is why it is the division of 2 is required right here to eliminate all of the invalid pairings right here. So the possible pairings is 6 and the invalid pairings is 3. Then of course we are dividing it by 2, so we only have the 3. 6 divided by 2, which is equal 3. And so I hope you get the better idea of this implementation, and I hope you also understand this explanation of my video. And if you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this implementation, you can also tell us what you think in the comment section. I will happily answer it. I hope you have a great day, and I will see you in the next video. Goodbye.